Hi everybody, it's Miss Billingsley. Today I'm going to go over the polynomial area discovery activity and how it relates to what Miss Martinez taught you in the 7K9.1 notes video from last week. So this task is so important for the survival of the rest of this unit. So if you have not attempted this activity yet, definitely pause here and try a couple of the problems before we start. I'm actually not going to go over them all. I'm going to start with activity number 2 and do a couple with you and just show you that connection of area to the distributive property. So let's get started. I'm going to start with question or task number 2. So here we have task number 2. We're asked to calculate the area of each house lot by filling in the boxes and then find the total area of all 4 houses or all 4 house lots below. So what we're going to do first is find the area of each rectangle, okay? And then we're going to find the area of the total, all 4 house lots put together. So let's get started. First, I'm going to start with this upper left-hand box. And the area here, we find area by multiplying length times width, okay? And length here for this top left box is x. The width is also x. So here I get x squared as the area for that lot. Okay, now we're going to do the next rectangle, which is going to be this one here. Okay, and its width is 9 units and its length is x units. So 9 times x gives me 9x. Okay, next we're going to look at this rectangle here, whose length is x and width is 4, so 4 times x gives me 4x. And last but not least, we're going to look at this box here. Its length is 4, its width is 9, so 9 times 4 gives me 36 units, okay? So in order to find the total area, what we want to do is combine all of the like terms. So we're going to combine the ones that have the same exponent values. So the exponent here is 1, and those are the only ones that can be combined. So my total area, we're going to add all of those together. X squared plus 9x plus 4x is 13x. And then we'll add on our 36. Okay, the units here are meters squared, so that'll be tacked on at the end. That doesn't affect my numbers, it's just the units on the end. Okay, so as Ms. Martinez showed you in the notes video, we are technically just multiplying 2 polynomials here. On top, I have x plus 9. On the left, I have x plus 4. So this is kind of the area model for distributing, so distributive property. We're doing the exact same thing, just in 2 different ways. Here, what we're doing is distributing our x to everything in the other side. So I'm going to start by multiplying x times x. That gives me x squared. Okay, and then I'm going to distribute the same x to this 4 over here, and I get 4x, positive. Now I'm going to distribute the 9 over here to this x. So again, I'm adding on another 9x, and then 9 times 4 gives me 36. Okay, so notice that these are the same pieces that we had above. So let's see if I can get the right color. My x squared is this area that we had for this first rectangle. My 9x is here, okay, and then I had my 4x right here, as well as here, and my 36 is here and here. So technically, we're getting the same answer both ways. All I need to do here is combine my like terms, so that gives us the 13x that we had above for our total area. So both ways we're doing it, we're getting the same answer. One way is called the box method, where we are, it's an area model. We're finding the area and then combining our like terms. Down below is what we've done before the distributive property, just now with more terms. So we have a couple options when we're doing this. Let's take a look at task number 3 next. Pretty similar, we're asked to find the area of a soccer field with a length of x plus 5 and a width of x plus 2 yards. And then we're going to find the total area. Okay, so when we're filling out the top and bottom boxes, it doesn't matter which one goes where. We said width was x plus 5, so I'm going to write that in separate boxes. X is one term, 5 is another. And then I'm going to put my width on the side here, x plus 2. That's a positive 2 and a positive 5. Okay, just like before, we're going to find the area of each box by multiplying. X times x gives me x squared. X times 5 gives me 5x. Okay, x times 2 gives me 2x. And then 2 times 5 gives me 10 right here. Okay, so when we combine all of our like terms, these are alike. So we're going to get x squared plus 7x plus 10. Again, we can do the same thing using distribution. We can multiply the length, the total length, and not just the pieces, but the total length is x plus 5. Total width is x plus 2. And using our distributive property, we can multiply x times x, which gives us x squared, x times 2, 2x. 5 times x is 5x. And then 5 times 2 is 10. Again, same answer we got above once we combine those like terms. And here our units were yards. So area is squared. So yards squared is going to give us that total area. X squared plus 7x plus 10. Okay, so again, we can use the area model. We can use distribution. They do the exact same thing. One is kind of a visual way, and the other one is just more procedural with that distribution. Okay, I'm going to look at one more. Task number 4 has a trinomial and a binomial. So now we don't have a situational problem. We're just told to multiply these two together. So one way to do that is using the box method, and that has been set up for us. So yeah, let's try the box method first. This one is a little bit different. When we multiply x times x squared, we're actually going to add those exponents and get x cubed right here. Same thing all the way across. When we multiply, we're going to add the exponent. So x times 3x gives me 3x squared. 2 times x gives me 2x. And then we're going to do the bottom row. So we get 5x squared here. We're multiplying the 5 by everything up above. So 5 times 3x gives me 15x. And then lastly, we get 5 times 2, which is 10. Okay, last thing to do before we get the total area is combine like terms. Notice those are set up diagonally. So we're going to get x cubed. There's nothing to combine that with, but I do have 5x squared plus 3x squared, which gives me 8x squared. 15x plus 2x gives me 17x. And then nothing to combine with my 10. So my solution, when I multiply this trinomial and binomial together, is x cubed plus 8x squared plus 17x plus 10. Again, another way to do that is using distribution. So our first binomial is going to be x plus 5 times x squared plus 3x plus 2. Okay, using distribution, we're going to start by distributing the x to the x squared, giving us that x cubed. And we'll follow the same process all the way. Okay, once we get here, all we have left to do is to combine our like terms. So here I have a 3x squared and a 5x squared. Those combine to give us the 8x squared that we had above, as well as our 2x and our 15x, which gives us that 17x that we had. So again, the same answer, no matter which way we did that, either using distribution or using our area model. Okay, I hope you're starting to see the connection between the area model and multiplying polynomials. I hope this answered any lurking questions that you had. If not, shoot us an email and we will get you all set up. Thanks for watching.